Hello and welcome to my poster presentation for the topic Decarbonization Potential of the Glass Melting Process via Energy Efficiency Measures and Fuel Switching. The glass production is a very energy-intensive process with around 80% of the total energy demand being in the glass melting process, being located in the glass melting tank. Most of that energy is supplied by fuel combustion, where nowadays mostly fossil fuels are combusted to provide that energy. Nowadays, mostly air is used as an oxidizer for that combustion process, while for some advanced options, even oxygen is used as an oxidator. For the future, hydrogen is a very promising alternative fuel to provide that energy. It might be combusted either with air or with oxygen. As a specific energy demand is not well known today, we conduct a thermodynamic analysis of energy efficiency measures and fuel switching. Our thermodynamic model is built up on 4 parts. First, the melting process, where we determine the heat that is required for the formation and heating of glass in the batch gases. Next is the heat transfer, where we utilize electric boosting as an energy efficiency measure to provide heat. Within the heat transfer, we determine the electricity demand, the heat loss through the furnace walls, and the heat that is required from the fuel combustion. Within the fuel combustion, we determine the required amount of fuel and oxidizer for our combustion process. Lastly, our heat recovery takes the heat from exhaust gas and batch gases to preheat the oxidizer, and we determine the temperature of the preheated oxidizer and the flue gas output. This leads to our main question of what is the decarbonization potential of energy efficiency measures and fuel switching. Looking at the specific energy demand, it can be seen that the specific energy demand can decrease by about 17% compared to the natural gas air combustion when utilizing natural gas oxy-fuel combustion for the glass melting process. Looking at the direct CO2 emissions, it can be seen that they can be decreased by about 62% compared to the natural gas air combustion when utilizing hydrogen as an alternative fuel for the glass melting process, leaving only behind process-related emissions. This leads to our conclusions that regarding the specific energy demand, changing the oxidizer to oxygen is more favorable than a fuel switch towards hydrogen without changing the oxidizer. Second, that a fuel switch towards hydrogen instead of natural gas is favorable to reduce the direct CO2 emissions. And lastly, that hydrogen oxy-fuel combustion is most promising in order to reduce both a specific energy demand and direct CO2 emissions. For more information, please refer to our paper.